And welcome back. So today we are going to be solving quadratics, one of my favorite things to do. Um, okay, that's actually not too far from the mark. I actually enjoy solving quadratics, so they're little puzzles. So what do I mean by when I say a quadratic? Well, I mean anything where the highest power is a square. So x squared equals 5 is a quadratic. X squared minus x minus 6 is a quadratic, equals 0. Um, so any equation where your highest power x is 2, okay? That is a quadratic. And they look like almost always a parabola of some sort. So that's what a quadratic typically looks like, something like this, okay? So we're going to cover how to solve these things for x. What values of x make this a true statement? So we're going to go over 3 methods today. And the methods couldn't be better. One of the methods you're not going to like. I hope 2 of the methods you do like. So let's start with one of the ones that I think you're going to like. Method number 1, the square root method. Okay? Square root method is something that we've sort of been doing all along. We just haven't explicitly stated it. So if I had something like x squared equals 9. If I want to solve this, one way I can do it is to take the square root of this side, the left side, because if I take the square root of a square, it leaves just the actual term. So in this case, if I take the square root of x squared, I'm going to be left with x. So if you can imagine, this is not what's really there. There is an imaginary root right here and an imaginary root right here. Now the difference is that when I normally say square root of 9, I mean 3. I do not mean negative 3, because this root symbol, if you remember from way, way back when we went over this is the principal root. As soon as you use the symbol, you lock in the value, the sign of the number that's underneath it. So in this case, it is a positive 9, so the answer had better be a positive 3. The negative 3 is excluded. But when we use the square root method, we actually want both solutions. So when you take the square root of both sides, the right-hand side always has a plus or minus in front of it. Plus or minus root 9 in this case, which is plus or minus 3. Those are the solutions, because if I look at my original equation, x squared equals 9. What can I square to get 9? Well, I can square 3 to get 9, but I can also square negative 3 to get 9. So that's why we have this plus or minus here. When I take the square root of both sides, the right-hand side always has this. Like, it's on fire. It's so important, that plus or minus. Oh, if this helps one person remember it, I'm okay with that. So let's do another quick example right over here. We got space. What if I say x squared equals 25? Well, take square root of both sides. X is equal to plus or minus root 25. What is root 25? 5. So equals plus or minus 5. X equals plus or minus 5. So if I plug in 5, do I get 25? 5 squared? Yep, that equals 25. What about negative 5? Yep, that also equals 25. So the answer is plus or minus 5. Just remember, when you take the square root of both sides, you always wind up with a plus or minus over here. Alrighty, so let me clear this. Let's do some more examples. So the way that you can think about this is we are going to follow the same steps every single time using the square root method. This is what makes it such a nice method. First step is always isolate the root on the left side. Okay? So if I have x squared minus 9 equals 0, before I start this method, I need to isolate the square on the left side. So I need that square on the left side and move everything else over to the right. So in this case, I'm going to do plus 9, x squared equals 9. The second that I have isolated the, and I just said root. Y'all, I'm going to say root forever. I can't help it. It's habitual. The square on the left side, not the root, the squared term on the left side. When you isolate the square term on the left side, move everything else over to the right, that's when you take the square root of both sides. So now I take the square root of both sides. I'm left with x equals plus or minus root 9. X equals plus or minus 3. Okay? So let's do another one. X squared plus 2 equals 7. I need to isolate the square on the left side. So minus 2, x squared equals 5. Now that it's isolated, I take the square root of both sides. So I guess 2 could be take square root of both sides. Root of both sides. Okay? So if I take square root of both sides, I get x equals plus or minus root 5. And don't forget, that root 5 has that plus or minus in front of it. It's on fire. Always have that plus or minus there. Okay? Alrighty. So now that we've got the steps for the square root method, you isolate the square on the left side, take square root of both sides. Let's do a few more complicated examples. So clear this. Oops, I still got my pen in the wrong color. Clear that. And let's tackle some more examples. So for the first example, let's try, wrong pen color again. My goodness, that'd be dangerous if I had good sense. Let's try x plus 7 quantity squared minus 5 equals 0. Okay, so we've got our equation here where we have a squared piece and a non-squared piece. What we want to do is isolate the squared side, so I'm going to add 5 to both sides in order to isolate it. When I do that, I have, well, that was a weird looking mark. Try that again. X plus 7 quantity squared equals 5. And now I'm going to take the square root of both sides. So square root, square root. When I take the square root of a square, it undoes the square. So I have x plus 7 on this side equals plus or minus root 5. Okay, now all I do is subtract 7. And when I do that, I'm going to wind up with x is equal to negative 7 plus or minus root 5. This is the way that you want to format it, where if you move something over where to a side that already has a plus or minus with it, put that value in front of the plus or minus. It's a lot cleaner than saying this is just awkward. Plus or minus root 5 minus 7. Yeah, that's not so nice. So, ugh, I don't even like looking at that. Alrighty, let me erase that one. That's just terrible. So you put the value in front of the plus or minus. Alrighty. So what if we had 2x plus 4 quantity squared minus 13 equals 0. Well, we want to isolate the square first, so plus 13, and we're going to have 2x plus 4 quantity squared equals 13. Now we're going to take the root of both sides since the left side, the square, is isolated. So root this side, we'll just undo the square and leave me 2x plus 4 equals plus or minus root 13. Now I'm going to subtract 4 from both sides. When I do that, I get 2x equals negative 4 plus or minus root 13. Divide by 2, divide by 2. Well, x equals this. This is your answer. I can't break it down any more than that. So negative 4 plus or minus root 13, all of that divided by 2. That is your answer right there. Okay? Not too bad, right? So that was the first method, which is the square root method. Let me clear this and we'll move on to the second method. So the second method is called, this is number 2, completing the square. Alrighty. So this is my favorite out of all the techniques, but it only holds for a certain set of quadratics. Okay? If I have something that's already in the form x squared something equals something, well, where this is like plus 3 and I don't know, 8. That is you use the square root method for that. That's a quick, easy solve by subtracting 3 from both sides. X squared equals 5, x equals plus or minus root 5, right? Completing the square is what you would use for a different form of quadratic. So the quadratics that it works well on are where there is a 1 in front of the x squared, or nothing. It's just an assumed 1. Okay? Second thing is I have an x term, something I didn't really have over when I was doing the square root method. So I've got an x term, maybe minus 7 equals 0. The number, the coefficient in front of my x is even. So there's a 1 in front of the x squared and the number in front of the x is even. If I have those possibilities, I'm good to go. I'm going to use completing the square. Alright, so completing the square is done with the same steps every single time. Number 1, move the number to the right. Okay, so I'm going to move this 7 over. So plus 7, x squared plus 4x equals 7. Notice I left a space there. Okay, what goes in that space? Well, step 2. I'm going to call this number in front of the x. If you think of a quadratic being of the form ax squared plus bx plus c equals 0, then I'm talking about the b, but it's the number in front of the x. So half the number in front of the x, or the x's coefficient, or if you would like, b in front of x, which I'm going to say is my b if it fits this form up top. So you half it. So step A is you half it. So in this case, I'm going to do a little scratch work over here. 4 over 2 equals 2. Okay? Part B, square that value. Okay? So 2 squared equals 4. Okay? So I take this value now, add the result to both sides. Okay? Here's where the space comes in handy. Plus 4, plus 4. Okay? Now, if you've done this right, if the middle term was even, or if it was odd, but gosh, don't do it if it's odd. You wind up with fractions, which are not as much fun to work with. But if it is an even number, I half it, and then I square that value, and the result I add to both sides. I add it to the left side and the right side. Okay, why did I do that? Because now this quadratic is a perfect square waiting to happen. What do I mean by perfect square? This is, if I factored it, 7 plus 4 is 11, I would get x times plus 2 plus 2, or x plus 2 times x plus 2, I should say. So these are exactly the same, so I can rewrite that as x plus 2 squared equals 11. See where I'm going with this? Now the square root method kicks in. I take the square root of both sides, so x plus 2 equals plus or minus root 11, minus 2, x equals negative 2 plus or minus root 11. So the whole game is to try to get this left piece to where it will factor into exactly the same thing. If it does, then you can write it as a square. Once the square is isolated on the left, which it is right here, I can then take the square root of both sides. And once I take the square root of both sides, it is a quick and easy solve. Okay, so you add the result to both sides. Let me do all the steps. I kind of got in front of myself. Form the perfect square. And last step, use square root method. Okay, oh boy, yeah, that sort of worked. Use the square root method. Alrighty, so let's do another one. And this, I'm not going to want to keep these steps over here. Okay, so let me get my eraser giant to get all this quickly. There we go. And we already know it's called completing the square. Let's do another example. Okay, so how about x squared plus 6x minus 3 equals 0. There is a 1 in front of here, and this number in front of my x is even. That is a perfect square candidate. So what do I do? First thing, move the number over. Plus 3, x squared plus 6x equals 3. Okay? Now, take this, half it, and square it. So 6 over 2 equals 3. 3 squared equals 9. Add that to both sides. Plus 9. So x squared plus 6x plus 9 equals 12. Now I can form the perfect square. This is going to be x plus 3 equals 12. That means I have x plus 3 squared equals 12. So now I can take the square root method and solve out. So take the square root of both sides. I get x plus 3 equals, smaller size 2 so I don't erase everything. X plus 3 equals plus or minus root 12 minus 3 minus 3. X equals negative 3 plus or minus root 12. Okay? You do it the same way every single time. Alrighty, now, this is the square root method. It's the second method, and I usually only use it if there's a 1 in front of my x squared, and the coefficient in front of my x is even. If both of those aren't the case, I typically go for the third way to solve quadratics. So let me go to the number 3. Clear this. So number 3, quadratic formula. This is what most students like. And since I can't force you to use any of the methods, I suspect many of you will use the quadratic formula method rather than completing the square, or square root method, so that's okay. It's okay. So quadratic formula, what is it? Well, it is x equals negative b plus or minus square root of b squared minus 4 times a times c, all of that divided by 2 times a. Okay? Where are these a's and b's and c's, you ask? Well, when I have a quadratic formula that is written like ax squared plus bx plus c equals 0, when everything is on the left side and it's equal to 0, the number in front of your x squared, the coefficient, is your a, the number in front of your x is your b, and then the plain old number is c. So you've used this one, I'm sure, for a long time now. You've been using this, so this is probably more of a refresher than anything else. But let's say I had 3x squared minus, you know what, let me do something that I know is going to come out right before I go into something crazy. Let me try x squared minus 3x minus 10 equals 0. Okay, so x is equal to, nope, that is not what I do. That is what everyone wants to do, and it drives me up the wall. That is not what you do at the beginning. At the beginning, before you do anything, you label what your a, your b, and your c are. In this case, a is 1, because there's a 1 in front of x squared. B is negative 3, that's the value in front of the x, and c is negative 10. I can't tell you how many mistakes it saves by labeling what my A, my B, and my C are before I plug it into this formula. You don't have to, but I do this. When I'm doing the quadratic formula, I write out what A, B, and C are, and I've been doing this for a long time. We'll just leave it at that. And I still write this out because it has saved me so many mistakes. So, up to you, but I highly recommend you write out your A, your B, and your C before you ever plug into this formula. Now I plug into the formula. X equals negative B, so negative 3 plus or minus the square root of B squared, so negative 3 squared minus 4 times A, 1, times C, negative 10. And all of that divided by 2 times A, which is 2 times 1. Okay? So this is equal to 3, because negative, plus or minus square root of negative 3 squared is 9. Negative 4 times 1 is negative 4, times negative 10 is positive 40. So plus 40 over 2. Okay? So this becomes x equals 3 plus or minus root 49 over 2, which is going to be 3 plus or minus 7 over 2. And I'm fine if you leave it just like this. If you don't want to leave it like this, my x is equal to 3 plus 7 over 2, and x is equal to 3 minus 7 divided by 2. So in this case, it would be 10 over 2, x equals 5. In this case, it would be negative 4 over 2, x equals negative 2. Okay? Those are my answers right here. But you can leave it in this form right here, because that's exactly what this means. It's just not quite as obvious what the values really are. Alrighty? Let's do another example. Oh, you know what? I'm going to erase because I really don't want to write that out again. So here we go. Erase. So let me give you a good problem. Let's say maybe 3x squared plus, let me do minus just to make sure I do this the way I want to. Minus 5 equals 2x. All right. So, can I write down my a, my b, and my c before I plug in? Well, sure. Except there's a problem. This is not equal to 0. This is equal to 2x. I have to move everything to the left before I can start using quadratic formula. So I'm going to subtract 2x, and I'm going to wind up with 3x squared minus 2x minus 5 equals 0. Now I'm good to go. A equals 3, B equals negative 2, C equals negative 5. I don't look at this equation anymore. I look at this and my formula. So x equals negative b, so negative 2 plus or minus square root of negative 2 squared minus 4 times a, 3 times c, negative 5. And all of that over 2 times 3. Okay? So x equals negative 2 is positive 2 plus or minus square root of negative 2 squared, 4. 4 times 3 is 12 times 5 is 60. So plus 60. And then over 2 times 3, 6. And I want to swing up here and continue. X equals 2 plus or minus root 64 over 6. X equals 2 plus or minus 8 over 6. And we are done. Okay? So, once I moved everything over, the big tip-off, I wasn't going to use my completing the square, which I dearly love, is that there was a number other than 1 in front of my x squared. That leading coefficient, if it's not a 1, you're going to have to divide it out in order to use completing the square, which is more work than it's worth. At that point, I use quadratic formula. So, there you go. Now, I hope this has been a refresher for the quadratic formula. If you run into any problems with it, come to the office hours, Zoom meeting, or something like that. Send me an email, and I'll see what I can do. But it's much easier to see me when I'm in the office hours, simply because I'm getting dozens and dozens and dozens of emails every day, and I'm doing triage right now. If it's not an emergency, it gets shuffled a little bit because it's a lot of emails. So office hours definitely a better bet. But if you can't make it, that's okay. Just send me an email. Alrighty, now let me clear this, recap, and give you your homework. So here we go. To recap, we went over 3 ways. First way was the square root method. When do I kick out the square root method? Well, I use this when there is a square that I can isolate. Use when you can isolate the square. Now, what do I mean by that? X squared plus 5 equals 10. I can isolate that square. X minus 3 squared minus 2 equals 7. I can isolate that square. What I don't want to do is x squared plus 7x minus 2 equals 0. I can't isolate this square without having an x on the left and an x on the right, which is going to make a mess. One thing I didn't explicitly state is that your square needs to contain all your x's or you're going to have a mess. You can get around it, but it's a mess. It is way more work than it's worth at that point. But if your x's are all part of a perfect square already in existence that you can isolate on the left, square root method all the way, so fast. Okay? So that's when you want to use it. Method 2, completing the square. Completing the square, we've already talked about when you use that. You use when the leading coefficient, when your a is equal to 1 and b is even. That's when you kick out completing the square. Way, way, way faster. X squared minus 10x minus 4 equals 0. Leading coefficient a is 1. The b is even. So I'm good to go. Plus 4 plus 4. X squared minus 10x equals 4. Half the negative 10, so negative 10 halved is negative 5. Negative 5 squared is 25. Add that to both sides. So I'm going to get it right here. X minus 5 quantity squared equals 29. Swing up here. Take square root of both sides. X minus 5 equals plus or minus root 29 plus 5 plus 5. X equals 5 plus or minus root 29. So that's when I use completing the square. Now, when do I use quadratic formula? Well, when I don't use the others. I won't lie. Quadratic square. I was sitting there thinking about completing the square. Quadratic formula is used the vast majority of the time, 80% in the real world, if not more. The reason that I'm showing you the other methods is because they are fast and you make less mistakes once you get used to them than you do with quadratic formula. Quadratic formula, the negative bx equals negative b plus or minus b squared minus 4ac, all that over 2a. It is a wonderful formula. It works very well. All you have to do is make sure that your stuff is in the form where everything is on the left and it's equal to 0 before you pick out your a, your b, and your c. That's the only thing you have to do to make sure the quadratic formula works. There is one big problem that people have with quadratic formula, and that is once you get to something that looks like x equals, I'm just making this up, negative 4 plus or minus root 3 over 2. Leave it. Don't simplify it. Don't do anything to it. Walk away. Everyone wants to go, oh, I can divide this negative 4 by this 2. So I'm going to wind up getting negative 2 plus or minus root 3. No, that actually is incorrect. The only way I could get rid of this 2 is if there's something that the 2 goes in evenly in front of this root as well. Now if I had negative 4 plus or minus 2 root 3 divided by 2, that would equal negative 2 plus or minus root 3. Because I could divide the 2 into the negative 4, get negative 2, 2 into the 2 root 3 to get root 3. This is wrong. This is correct. But when people get to this step, they want to simplify. So they just go ahead and divide in. So if you don't do that, you're in good shape. Alrighty. So for your homework, well, now that I've said all that, knock out the following. Okay. Your book has okay examples, but honestly, I really don't like the way that it handles setting up all of these. It gives 2 examples and both of them are not typical, which just drives me crazy. So here we go. For your homework, do the following. Use method 1, square root method. on the following. X minus 7 quantity squared plus, let's see, 1 equals 10. Solve that using the square root method. Okay. For the second one, use completing the square. Knock out this one. X squared plus 12x minus 4 equals 0. Last one, use quadratic formula. 2x squared plus 5x minus 3 equals 0. Okay, solve these three using square root method for the first one, complete square for the second one, quadratic formula for the third one, and see how it goes. And I can't stop you from using quadratic formula for every one of them on the exam. So at the very least, just pay really close attention to the quadratic formula. Okay, so with that, y'all, I hope you have a great day. Stay safe, and I will see you later. Bye-bye.